Today, the topic that we're going to discuss is another important topic, that is energy, work, and power. We're going to study it all together because somehow, when it comes to exams, these topics are mostly interrelated and the formulas are very connected to each other. And the questions is mostly a combination of all these topics. So, starting with energy is, as you can see, the energy's ability to do work. Work is defined as product of force and displacement, and power is defined as rate of doing work. So starting with the energy is divided into two major sections, which is uh, mechanical energy and so energy is divided into two parts. One is mechanical energy and the second one is electromagnetic energy. If an energy is medium dependent, that would come under mechanical energy. That is, a medium dependency is important, that is mechanical energy, and if it's medium independent, then it's an electromagnetic energy. For example, light does not need any medium. Light is a form of energy, does not require any medium for its propagation. Whereas mechanical energy, we could say sound is dependent on medium. Without air or the vibration body, sound could not be produced. After this, mechanical energy is further divided into two types: kinetic energy and potential energy. Kinetic energy is the energy which is possessed by moving bodies. Anything that is moving have kinetic energy, and potential energy is possessed by a body due to its position or height. Height or position, due to these two circumstances, the and always remember, energy is always there. That we're going to study later as well. Energy is always there. We are not creating it nor destroying it. We are only using it. That's where the second topic that we're going to discuss is energy stored and energy transferred. Transferred and stored. From there, we'll focus that energy is always there. We're not creating it. We are just using it for our own benefits. So getting back to the topic, that mechanical energy is further divided into kinetic energy and potential energy. Kinetic energy is due to the motion of the body, so it will depend on mass and velocity, and the formula would be 1 by 2 mv square. Potential energy, as it is dependent on the position or height, so the formula would be mgh. Mass, gravity, and height. Similarly here, mass and height. The derivation of these formulas at your level is not important. So only thing that you need to keep in your mind is kinetic energy formula and potential. Both are scalar quantities and both have the units of joules. Joule is equals to kilogram meters per second. Then after this, moving on to the next part, uh, everything lost here. So nuclear fission, and when a bigger nucleus split up into two smaller nucleus, and nuclear fusion is when two smaller nucleus combine together to give a bigger nucleus. This occurs in nuclear reactors. Fuel is uranium, and fusion occurs in sun, and fuel is hydrogen. So fission and fusion. Fission is breaking and fusion is combining. These are again a part of energy stores. And then magnetic energy, thermal energy. We are familiar with thermal energy. It's also associated with the internal energy. So an atom has a nucleus at its center that is made up of particles bound together by strong forces. In some atoms, the particles becomes rearranged or nucleus split. Stored energy is released. Whereas on the thermal energy is the particles are moving, so they store energy. When a hot object cools its particles, we normally have noticed that when a hot particle cools down, energy is released. Or when a water is heated up and left in a pot, you'll see the steam coming out of it. That is the energy that is being released. Or so when an object is hot, its internal energy increases. When an object cools down, its internal energy decreases. Here we can also discuss that internal energy is the sum of all forms of energies that a system possesses. Here you could see, moving on to energy transfers. When it comes to energy transfer, we focus on the thing that energy transfer, there are certain forms of energy which you can not store but only could transfer. This is the mechanical energy, electrical energy, heating, thermal energy, because a temperature difference, heat is a form of energy, and radiation, that is sound and light. We cannot store these energies, we can only transfer them from one form to another. Here you could see in this example that how energy is transferred. The kinetic energy possessed by the cycle, when it start moving up the hill, its kinetic energy start converting into Gp. When it reaches the maximum height, its kinetic energy has been completely converted to gravitational potential energy, and when it comes back again, Gp converts to kinetic energy and then kinetic energy again. Similarly, if we discuss about the energy changes that occurs in a torch, so the battery has chemical potential energy stored into it, which is converted into electrical energy and then converted into light and thermal. Here thermal energy will serve as a waste energy because we are not requiring it, it's not something that we're looking for, so it will appear as a waste energy. That will discuss what to do with these types of energies which we are not, which is not required in required. So we'll discuss in conservation of energy. Similarly, in a TV, electrical energy is converted into sound energy and thermal energy. Again, the thermal energy is the waste energy. These types of questions comes under the Sankey diagrams that discuss the energy transfer that is occurring. We can also discuss a very good example. You could see, you must have studied in the previous chapters that velocity changes over a period of time. So if an object is going up, so the moment it will leave the hand, it will have the maximum velocity. Then as it's going up, its velocity keep on decreasing, and at maximum height, its velocity becomes zero. And then when it start coming back, its velocity starts to increase again, and then eventually becomes maximum just before touching the ground. So if we associate this with the motion of the pendulum, so we could say that when the object is about to, when at its maximum height, it will have Gp. So at maximum height, its maximum the total energy is Gp. At in between, there would be Gp and kinetic energy. At mean position, there would only be kinetic energy, and that justifies too, because there's kinetic energy only because then it will go back to its new position. So these two are the extreme position. The distance between these is the amplitude. So again, at the other highest point it will have, so we have studied already in chapter number 1 that when one oscillation is completed, that when object is released, it's from here, and when it comes back to this position when oscillation is completed. So at the extreme positions, the only energy is Gp. At mean position, the only energy is kinetic energy, and in between is the sum of kinetic energy and potential energy. Similarly, if we discuss this example, so the energy stored in our muscles is chemical potential energy, the energy stored in, so when we throw the stone, that chemical potential energy is converted into kinetic energy. Then as it's going up, the kinetic energy is converting into Gp, and when it's coming back, Gp converted to kinetic energy. When it touches the ground, all of the energy gets wasted into the thermal energy. So these are the few examples that will help you to understand that what is the meaning of energy stored and how the energy is transferred, and how to make the diagrams and how to discuss the energy changes that is occurring in a certain system.